Testing. All right. So, testing. Welcome. Is this working? Yep. All right. It's working. Hello, everybody. Welcome back. Omega Given here. So, today we are going to be 3D modeling. So, I did a 3D model stream where we kind of created. Actually, no, I didn't do a 3D model stream. I think it was actually just a tutorial. Yeah, it was a tutorial on how to make a drain kind of object. And well, I created the drain object. I 3D printed it out in TPU plastic, which I need to do a quick research. TPU versus material versus weather. How good is it against weather? TPU generally exhibits good weather resistance, including resistance to UV radiation, moisture, and temperature fluctuations, making it suitable for outdoor applications. However, some TPUs can yellow or degrade over time with prolonged UV exposure. So, I expect this to be decent. Yeah, I think this will be just fine. So we have the TPU plastic drain plug, which is interesting because normally this is not made out of TPUs. Normally made out of ABS piping stuff that you might find at Home Depot or Lowe's or something like that. And we measured it wrong. It's apparently 4.125 size. So we need to go and correct our model a bit. And also I have some other, I don't know, aspirations for this. So what I'm going to do is we're going to keep it how it is, kind of, I guess. We, for one, need to do a little bit of some editing here. So we need to delete these little chamfers, I think that's what they're called. Yeah, we need to delete these chamfers because I need to actually extend this a teeny bit more because it wasn't actually long enough. I think like doing the chamfers kind of shortened the sizing of these holes. Also, actually, no, I got a couple other things I gotta do with this too. A couple other things I gotta do with this 3D model is I think I need to make these a little thin. So sadly, actually, do these chamfer are these? No, those belong to other models. Okay, so sadly, I could basically remodel this from scratch. It probably won't take me a horrible amount of time. Or we kind of edit this model a bunch, like a heck of a bunch. Basically what we could do is just get rid of all these chamfers really quick. Basically what we could do is delete or split this model and then redo the whole divide parts of it. I think that might actually be what we do here. All right, I think we got rid of all the chamfers. It looks like they're all gone. Yep, they're all good. Okay, so let's see here. How are we going to do this? I think the top of it is fine. So we're gonna keep the same size, but what we're gonna do is in our slicer over here, we're going to scale it up because you can scale it. So we're going to try to scale it to the perfect amount. Because right now it's 101.6 millimeters. So 4 inches, let me do a quick conversion. Inches to millimeters. Actually, also quick calculator. 1 divided by 8 is 1.25, right? Or 0.125. 0.125. So it'll be 4.125. So we need to scale this up. But I want to edit and, perfectionist this thing up a bit. So what we're going to do here is we are going to do a quick create sketch on that flat surface. We are going to hopefully find the center circle point. And sadly to us, this center circle point does not like to, doesn't match up with crap. I don't know which one it was doing it on because it's not actually matching up to anything. Oh wait, is it now matching up? I don't know if that's actually matching up to the edge of the circle or not. It does not look like it's actually matching up to the edge of the circle. That's the problem I have with a lot of these things, is I don't know when it actually does match to the edge of the circle. Gosh, I gotta hate it. You gotta hate it. It's so annoying. Yeah, there it is. So we made a sketch to that so we can make it to there. There we go. That's much better. Okay, so we're going to do that and that. We're going to finish that sketch. We'll come back to that sketch in a second. Basically, what we're going to do is we're going to do extrude, and we're going to do -50. Or no, +50, not negative. +50. That should get rid of that because I think we made those 50 tall. So boom, we got rid of our 1 stuff. So now we can recreate it. I think in my one live stream I did a 30 divide. But we're actually going to do a little bit different on this one. We're going to make this extend a little bit more. We're going to make this extend 50. So we're going to go do another -10. Actually, let's do -5. I think, or what's not 15, 5. I think that will be enough. So it'll be 55 millimeters high is how high we're doing this divide thing. Now that we have that, oh gosh, I got so many stuff going on here. Let me go to this sketch again. We're going to edit the sketch real quick. Also, actually, wait, let me hide this body on the top. We don't need to see that body for a second. We'll recombine it in a second, but we don't need to see it. Okay, now what we're going to do is we're going to do our little line thing. We're going to put a line here all the way through to the edge of this circle. Nice line. It really doesn't need to even be on the circle, actually. So we're just going to do that. Then what we're going to do is we're going to grab that line. We're going to create a circular pattern. Center point being the center of this. And then we're going to divide this into 50 things instead of 30. I think that will be good. That'll be a lot more and a lot thinner, making it so particles and objects don't get stuck in our, or they don't go through. We want them to get stuck. We don't want them to go through our drain. So we'll do 50, and then I think what we're gonna do is just gonna do like we did before. 1, 2, 3, 4. I declare a thumb war. Oh wait, what the flip? Why is that not selecting both sides? That was a weird selection. Oh, I think it's because that was technically like its own divide or whatever. Oh, whoops. I didn't mean to select that one. If somebody knows any way to select all of these like better than just hand selecting every other one, let me know, because I would love to know. Oh yeah. All right, now we're gonna extend these by 55 like that. So now if we unhide that body, it should match up with it just like that. Looks good. We're gonna hide it again though, because I gotta do some work on this thing. All right, we can hide this sketch. We don't need this sketch anymore. So what we're gonna do here is we're gonna grab every single flipping edge. And what we're gonna do with these edges is we're gonna chamfer them all. Chamfer. So there's 2 big things you can do with 3D models when you're trying to create like good arches and stuff. You got chamfer and you got fillet. Yeah, that's what it is. Chamfer and fillet. Is it chamfer? No, modify. Chamfer. Yeah, it's chamfer. Chamfer. So basically what fillet does is it does an arc motion. So it looks like a circle kind of. What chamfer does is it just literally makes it flatten inward. Like, so it's a angle, like an angle just gets cut into it. And we could do either or, to be honest. We could do fillet, but I like chamfers because they're flat angles, and if you ever have to edit them, a lot easier to edit them. Also, it still works just as efficient as many other things because 3D printers like to go in straight lines, and a chamfer is a straight line. So I like straight lines. Straight lines are good for 3D printing. Curved lines are also good. Straight lines, curved lines. What sucks with 3D printing is right angles. It's not bad. Like, you could have right angles, But the con of a right angle is that it increases your print time. Very minuscule, but when you have a lot of right angles, like every single layer is a right angle, which it is, then you got long print times. So you want to fillet or chamfer everything you can reasonably chamfer or fillet reasonably. This one, like if we wanted to fillet chamfer every single thing, I actually would probably do all of these going up, but I kind of want to keep their integrity. Also, this is TPU plastic. TPU plastic holds together pretty well. So I'm just kind of, I'm not doing so well on the print time of this object. This print time is going to be like 8 hours, most likely. So not like the best print time. But hey, that's how we do things. All right, we have everything selected, I believe. It looks fairly evenly selected all the way around, blah, blah, blah. Everything looks good. We're going to right-click, create selection set. You create selection sets because if you mess up and you accidentally click somewhere else, you can re-click it. But we're not doing that. We're going to do chamfer, and we're going to chamfer it by... Where's the thing? Oh, crap. No. Something happened. It just like literally bonked out on our thing. What the flip? This is why you create selection sets. Oh yeah, see, selection set. This is why you do it. Perfect opportunity to show you why you should do selection sets. All right, we're gonna do this by 5, 2, 3. There we are. 3. 3 is good. It's a little point. Can we do 4? No, they can't do 4. We can do 3 though. Can we do 3.5? I just want to make a nice peak. Nope. 3.4? 3.3. 3.2. 3.1. 3.1 it is. All right, we're chamfering by 3.1. All right, there we go. Look at that. Delicious. Deliciousness. It has the same amount of area of drainage as the other one, theoretically. I just realized I chamfered the wrong side. We don't need this to be wait, no. Yeah, we don't need this to be chamfered. Gosh darn it. All right, Control Z. We need the other side to be chamfered. Why is because we're going to be 3D printing on this side, so you need the other side to be chamfered because it needs to, oh gosh darn it. All right, well, I'll tell you in a second. It'll make more sense once I unhide this body. So we 3D print this upside down. You see that? That is a bridge across. 3D printing doesn't like bridges unless your 3D printer is good at them, but we don't need the bridge. We can literally just, do whatever. So we're going to combine these two objects. Yes, combined. And then we got to do the whole selection set over here and chamfer these sides. Gosh darn it, us. Darn our stupidity. That is what we have to deal with. Our stupidity. We are stupid. All right. So let's go by select. I'll just select everything that I can visually see that is, oh, no, not that one. Right, this one. This one. This sucks when you have to select 100 in, wait, is it 100? Is it 100? I think it is 100. Because there's 50, I did 50 subdivides. And there's 2 per subdivide, meaning I think we do have to select 100 different things. This, you know what? Sometimes I've actually wondered. So my actual career job is programming, but sometimes I wonder if I could get by as a 3D modeler engineer kind of person. I don't know, something like that. I'm not really good at tolerances of material. I don't know what material tolerances are. So I'd definitely be like a select by, oh gosh. I'd definitely be like a person that has to test by trial and error. But hey, doesn't SpaceX do that? That's why they have so many blown up rockets over the years. Low blow to Elon Musk. Okay. Just trying to select all the 100 different edges. All right, so let me explain why we have to do this side and not the other side. So since we print this upside down, I did kind of explain it, but since we have to print this upside down, this would print upwards this way. So a 3D printer has to do a whole line all the way across here in order to create the next section, like that base section that actually goes into the hole in the ground for this drainage. So it needs basically a slightly like over time kind of arching over. So that's why we have to do chamfers, because it is that arch over top. So we are going to include that into our 3D model. And I think we are almost done selecting every single one. All right, let's go back. Did we select every single one? Okay, we got everything. All right, it's cool. All right, right click, everyone. Create selection set. You never know if you lose it. All right, modify, chamfer. And I think we chamfer by 3.1, giving us the perfect chamfer. All right, and we got ourselves a good looking 3D model. Woo, everyone clapping. Yeah, save as mesh. All right. Export as 4.4 inch drain. Actually, aren't these called certain things specifically? I think these are called. There's a name for this type of drain. Atrium. I think it's a 4-inch atrium drain. I think that's what it's called. A 4-inch atrium drain. Actually, I want to do all caps because this is probably my final design. Atrium drain. I like to do all caps for my final designs just because it's like final design. I can click on that one. It's all caps. It's easy to find. Stuff like that. Easy peasy. This is a peasy lemon squeezy. All right. We're gonna open our 3D models. 4-inch atrium drain. We're gonna delete our old one. I don't care about that model. And then we have to size this up because we did not do that last. Okay, so for one, rotate it. We gotta rotate this 180 degrees because we want to print it on the other side. It not rotating 180 degrees. I said rotate. Relative 180 degrees. Oh yeah, baby. All right. There we go. We have it rotated. It is like this. It is decent looking and everything. We need to now size this up. So we need a scale. So I think we need so this needs to be 104.775. 104.8 is rounding up, but that's okay because this is a very flimsy plastic, meaning we probably can still fit it in the hole if it's not, the tolerance is exact. So with that in mind, I think we're good. I think we got our 104.775 on those scales. It might be a slight difference on this here, but we did size that up, so that should be fine. We're going to slice and dice. Slice it and dice it and see how it does. All right, look at that. We got a couple seams, but the seams are okay. I kind of wish we could figure out how to get. I need to learn this stuff, how to get rid of seams. Total time. This is a 9-hour print. All right, we're gonna do it. We got the plastic. We're fine. We're gonna send it to the printer, and we can call this live stream over, I guess, because we're done. Yeah, we got nothing else to do. I'm sending it over to our 3D printer, and we should be good. It's 100 grams. What is that? A few bucks. Couple bucks of plastic, something like that. We can even look at our printer as it's actually, I can't do it well until it's downloaded. All right, I think we're good, guys. If you liked seeing how to do some 3D modeling in Fusion 360, this is the free version of Fusion 360, just by the way. Then like and subscribe. Go check that out, stuff over there and stuff like that. Yeah, blah blah blah. Cool stuff. All right. Also, I think this is done. I need to get this 3D printed sometime. This is my modified, good-looking stuff. I might sell this as a product sometime. We'll see. It's doing pretty good. I just need to 3D print it and test it, see if it works how I want it to work. I can't wait because I need a new because my old one, this one in my hands, it doesn't fit with my new cases on my phones, so I need a different one. So we need to get a different one. And then once we find that it is working how we want it to work, then we can sell it to all of you. We got to find some good bungees that we like though, because right now the bungees on it. Oh, it's not. Wait, I just realized that we don't have a bungee on this end. How dare we? How dare we not put a bungee? You know what? Guys, we're not in the stream. We're going to bungee this thing up. How did I do this bungee? I can't remember how I did that bungee. So we're going to do create sketch on this plane. I can't remember how we created that bungee. So we're going to have to do some experimenting, I say. Let's call this 2 or 3. One second. Control Z. I don't know if I want to do that. How thick is that? Like, that's a big chamfer, but how thick is... If I inspect here to, like, here... That's 2.7. I think, okay, so we made it 2. We made it 2. All right, good to know, good to know. All right, so we made that 2, meaning we're going to make this 2 wide, the length this way. Actually, now I think about it, we want no. We want to make, okay, we're going to do 1 this way because we want to get it away from this corner. So we're going to make it 1 that way, match that. Make it 2 this way, match that. Because we're going to need that 1 to, like, form into it, kind of. That's basically what we're going to need to do. All right, so we got that good. How... Let me inspect this. What? How this? That's a 1 millimeter radius circle, 2 millimeters wide. So we need to go up to 3, 4. Is it 5 maybe? Is it like that's how wide we need to make it? That's 2.5 up there. So it's 2, 4.5 tall. It is 4.5 tall. Good to know. All right. Okay, so we're gonna finish sketch, extrude this 4.5 tall. We're going to create a sketch on this plane. Ugh, I hate it when it readjusts. I'm like, just create sketch, don't readjust. I don't know if there's like a setting I can do to like fix that. All right, it's right here. This is the plane. Okay, so we want to make this plane 2.5. Making that circle that size. How exactly did I do it? Looks like I came out like a little bit. What's the radius of this? This is a 1.25 radius. Meaning, and is it a solid half? It is a solid half. So we want this to come out 1 point. Oh wait, no. We want this to come out. So this is come out 2.5, right? Extrude 2.5. I think we might want that to come out 2.5 because we're gonna fillet these 2 things right here to be 1. Yeah. Booyah. Look at that. See? 1. So that's our nice little nook. Fillet this to be 1. I realize this is not actually... Okay, we're going to extrude this negative 0.5, and we don't need that to be like that exactly. We're going to fillet this to be 1. Excellent. Look at that. See, that's a good cup thing. Like, this is like the... Oh, I just realized I'm doing this the wrong way. It needs to face outward. Because the bungee gets on that end, and then the other one needs to get on the other. I'm doing this wrong. I'm doing this wrong. Gosh darn it. I'm not good at this, am I? Wait, if I fillet this by 1, what does it look like? Oh, wait. We can recoup this. We can recoup this, indeed. Create sketch on this plane. Create sketch. Then find where the flip we were. We were right here. Okay. Okay. 2. Length of this. Wait. That doesn't line up. 2.5? Yeah, 2.5 is what we did. Okay, 2.5. Excellent. All right. Extrude this out. How much did we extrude the other one out? We already see we forget these things real quick. That went out by 4.5. All right, extrude this by 4.5. Booyah, baby! Look at that. I do not think it was 4.5. I think it was 2.5. Frick! Wait, what? Wait, what just happened? What just happened? There we are. Okay. Finish sketch. Extrude this by 2.5. What the flip is the... Gosh, okay. Okay, inspect this corner to this corner. That is 2.5. Yes, extrude 2.5. Booyah. All right, now it's a symmetrical T. The symmetrical T. All right, it's like this thing. Fill up those by 1. It creates a nice, perfect half circle. Matches with that. Delicious. And then we're going to take this thing and this thing and fill up these by 1. We realize that this needs to go in by -0.5 because I want this to be a perfect circle. So we're going to take this and this, fill up that by 1. Booyah. Look at that deliciousness. Just like woo woo with curves. How did the other one look exactly? The other one did the exact same. Woo woo, did curves. All right, cool. And then we don't need this to be coming out, so let's extrude that back in. -2.5. Booyah, that is gone. But big butts. Not big bucks. Don't quote that. Gosh darn us. All right, we're gonna chamfer this because we want this to work pretty well. Fillet, or no, not fillet. No, we want chamfer. We want chamfer, not fillet. Not filletes. Filletes. We want chamfer. That by 2, 3, 4. Yes, we're chamfering that by 4. Filleting this by 1. We can make this kind of like go pretty well. Oh, all right. 8 is the way to go. 8.125. We're just gonna do it by 8. All right, look at that. Look at that deliciousness. Yes, we have this on that end, this on that end. Now I think this is ready for 3D printing. It just took me a second to like make sure we get this done correctly. So hopefully if I got everything right, we can put a USB-C in here. This will make it so you can click the 1 button on the thing. This makes it so you can use the audio jack. I don't have a hole for the, is it mini HDMI port or something, the whatever port on here. And I mainly don't have that hole because it would interfere with this. So, but I don't think I've ever actually seen someone use that. So I think it will be fine as is. We're gonna do Control S save. We're gonna say Xbox FV2 final version 2. I think that's what I'm gonna call that. Let's see how our 3D print's doing. Did it start out? It did start out. It looks like there's a little nick right there that's not quite doing, but I don't think it's done with the first layer. And there's a little, it's like whatever. That's fine though. It doesn't need to be perfect, so I think that's fine. All right, so that'll take me 9 hours. I'm gonna wait 9 hours for that 3D print to be done, and then hopefully it'll fit in the hole. We're gonna put circles in holes. Sweet. All right, everyone, thanks for watching. I know there's like nobody that joined this actual live stream, but if you join it or watch this afterwards, thanks for watching. Hopefully you learned a couple things about 3D modeling with Fusion 360, and I'll see you all later. Bye-bye.